the next episode of C Programming. In this episode, we're going to talk about the variables. Variables are such an important topic in not only C programming language, in every programming language, and you're going to need them and work with them a lot during this course. So let's jump to our code. So let's see a simple code that we have here. Hash include stdio.h because we want C programming to know what we are talking about when we are talking about printf function or other functions that are available in C. And we are writing our code in the body of the main function as we said earlier. So here I want to print an integer plus another integer. By the way, if you haven't looked at the previous video about the printf function and how we can print formatted arguments, please stop this, go back, watch the video, and come back here again. Thank you. So %d plus %d equals to %d. I want to add some numbers and get a result. In this case, if I add 5 to 7, 5 and 7, I'll get 5 plus 7. Let's compile and run it. We can go to debug, start without debugging, or press Ctrl F5. You can see 5 plus 7 is 12 and everything is working. But let's be honest, this is redundant. If I know that I'm adding 5 to 7 and it's 12, why not just putting it into the string and not making it formatted a string and use the argument to replace it? As a matter of fact, that code would be much faster and more optimized. So why bother doing this? In fact, never we're going to put exact numbers in our arguments in the printf function. We are going to use variables. There are different types of variables in C programming. We use variables to store data, to manipulate data, and change data the way that we want. For example, we are engineers. In my case, imagine I'm writing a code to design concrete columns. Concrete columns have widths and height. And these, imagine the cross-section of the column is square. So the widths and the height can change. So it's better for me to store them in variables so we can manipulate them. Basically, in any program, we have input and output. Widths and height that we just talked about could be the inputs of the program, and the output could be the number of reinforcement you need in that reinforced concrete column. We need to store all of these. In C programming, there are many primitive data types that you can use. For example, integer. Let's go to the code and see how integer works. So here instead, I can say int var int var, let's call it var1, int var1 equals to 5. So when we define a variable, first is the type of the variable, int. Second is the name of the variable, which I named it var1 in this case. And the third part is equal to 5. This part is optional. You can just declare a variable and leave it there. But here at this point, I know the first variable is 5, so let's initialize it. I want to introduce another integer. Integer var2 equals to 7. So I have 5 and 7 in my printf function. Instead of explicitly saying 5 and 7, I can say var1, var2, and var1 plus var2. Okay. So let's print this to see let's print this and see what Visual Studio will give us. Ctrl F5 to compile without debugging. And as you can see, the result is 5 plus 7 is 12 again. This way, I can manipulate data. Here I can say var1 is equal to 9, and then copy the same code, place it after when we manipulated the data, and then compile and run the program again. And you see the result will change. But if I hard-coded 5 and 7 and 12, and this way I need to change and hard-coded 9 plus 7, 16, you get it. This is much faster, much easier to read. We have a wide variety of different data types that we can use. Another example would be char. Let's go back to the program. So I can create, let's get rid of all these, and now we're formatted. Okay, so I create a char called variable, and I'll name it, you can use single quote for characters. You can use the number associated with the character, but I'm going to stick with single quote and the character because this is more understandable, and we don't need to get too much details in C programming in this course. So I wanted to print it, my character is %C, and then instead of just putting A there, I can say variable. And if I control F5, I have an error, expected semicolon. We forgot the semicolon. So as we said, each command in C needs a semicolon at the end. So let's compile and run it again. Built successfully. My character is A. Awesome, it's working. But for storing decimal points, we have two different types. Let's look at it. So we have float variable equals to 10.2 and double var equals to 10.5. Both float and double are there to store numbers with decimal points. The difference is float is for storing single precision float numbers, and double is there to store double precision float numbers. But you have to tell C to consider it float or not, because as we said in the previous video, the default is double. If I hover my mouse on 10.2, it says it's double, and if I hover my mouse on 10.5, again it says it's double. If I add the character F, uppercase or lowercase doesn't matter, at the end of the variable, it will automatically know that this 10.2 is a float number, as you see. So how to print them? Again, as we did before, we use %f for floats, and I will stay variable, and I will add another one. It's not my character. My float number is, and I'm going to copy this and my double number is just that. And if I compile and run this code, you would see that the float number and the double number is printed successfully. All the data types that we talked in this video will be stored in the memory. In this case, integer will take 4 bytes of the memory. If you go to internet and search what is the maximum and minimum integer that you can input in C or any other programming language, you would see that the maximum is positive 2 billion and the minimum is negative 2 billion. It's because of the space compiler considers to store your integer. Integer is 4 bytes. Each byte is 8 bits. So 32 bits we have for storing integer. The first one will always go for the sign. It could be either positive or negative. The next 31 will be the spaces in the memory that computer will use, the compiler will use to store your integer. So each of those spaces could be either 0 or 1. If you have passed the probably in a statistic course, you would understand that there's a possibility of 2 to the power of 31 numbers that you can print using that 31 spaces. If you put that into any calculator, 2 to the power of 31 is 2.147 billion. But there is a way to increase that limit. You remember that I said the first bit is where we store the sign. If you know that all the integers that you have is going to be positive, or it's going to be positive, it's better to use unsigned. So there is a way to, if I have int var equals to 10, I can add keyword of unsigned before int. My unsigned integer number is, it needs to change to %d and var and control F5. Everything is working, but the maximum limit of this one is now 2 to the power of 32. Let's see, 2 to the power of 32 is in Google is 4.29 billion. So this way you can go from 0 to 4.29 billion. So this concludes our video regarding variables. Let me know if you have any questions and we can discuss more about it. Thank you for watching this video. Have a great day. See you in the next one.